All right, so let's take a look at number 3. Number 3 starts off looking very similar to number 2. It's written in logarithmic form, so that's our Benny, and we want to rewrite it in a way that we're used to seeing, right? We're used to seeing Ben in exponential form. All right, well, so let's rewrite it in exponential form and see what we can do with this. So this says 4 to the what power makes 101. So let's go ahead and rewrite this first of all in exponential form. So the base, right, Benny and Ben, base stays the same, so you've got 4, and it's just these other two that switch places, right? So that would become our exponent equals, and then 101 would be our number. So this says 4 to the what power makes 101. Well, if I tried 4 to the first power, I'm just going to do some scratch work here. 4 to the first power is 4. 4 squared, 4 times 4, right, which would be 16. 4 cubed, which is 64, right? And then if I do, and I'm thinking, wait, so 4 to the fourth power, that's not 101, right? Because if I kept doing 4 times 4, there's 16 times another 4 is 64, times another 4 would be 256. Well, so if I did 4 to the fourth power, that equals 256. Well, what happens is there's not an exponent, at least not a whole number exponent, that stops off at 101. You see that it jumps from 64 to 256 and jumps over 101. So what we're thinking is that since 101 fits in between here, right, in between 64 and 256, what we're thinking is that our answer then would have to fit somewhere between 3 and 4. So maybe I'm thinking it's, I don't know, let's just say 3.5 for instance, right? So like, let's say I tried 4 raise the roof 3.5. I get 128. Oh, okay, well that's a lot closer than 256. And then I could sit here all day if I wanted to and try to figure out, oh wait, okay, maybe it's 3.4, right? Because I got to get a little bit closer to 101. Oh, okay, 111, so I'm a little bit closer. So like I said, I could sit here all day and play with the numbers and try to figure out what it is, but we want a more exact way of doing it that's not kind of a guess and check, which is what we're going to do here. So a little formula for us, since we're looking for the exponent, right, which in this case is x. So what we would have is that we would have x is equal to log of the number, right? So whatever number is back there, in this case 101. So we're going to do log of 101 divided by log of the base, which in this case is 4. And this ends up being our change of formula equation here. And so this is a situation where we need logs. If you go back to that last problem, 5 to the what power makes 125, well, I don't need a calculator for that. I don't need logs because the answer is a whole number. But as we've already kind of seen with this one, the answer is going to be 3 point something. We're thinking maybe 3.3 or something in that neighborhood, but we need a calculator to actually figure out what that would be. So what we're going to do is that we're going to actually put that into the calculator. So clear that out. So we'll do log of 101 divided by log of 4. And we get 3.32, right? Which is close. We tried 3.4. That was a little too big, so we thought maybe it's 3.3 something. We don't have to worry about too much about the rounding here. I'm gonna do a little, since we're rounding, I'm gonna do little squigglies, and let's round it to 3. We can just say 3.33 is fine, right? So approximately 3.33. Let's see if that makes sense, right? So if I put in, because we said it was going to be somewhere between 3 and 4. Which 3.33 is. If I did 4 to the 3.33, would I get, let's do 4 to the 3.33, I get 101, right? And then because we round it, it's a little off, but we get the idea that 4 to the 3.33 would be 101. So again, I couldn't do that one mentally. I needed a calculator, and that's where logarithms come into play. All right, so, and we would express this, that whole chunk of it is our answer, because the fraction part here is the part before it goes into the calculator, and then the 3.33 just shows our approximation of what it would be. All right, so and actually later in the video we're actually going to come back to look at this problem, because you notice the instructions say use the change of base formula, which is what we did right here, or your knowledge of log properties. We haven't talked about log properties yet. We're going to talk about that a little bit later in the review. So for now, let's just leave it here, and we'll come back to it. All right, so try number 3 on the right side.